Imagine getting hit by a baseball thrown at nearly the speed of light. That is essentially what Earth's atmosphere experiences every time one of these particles arrives. And we have absolutely no idea where they come from. Right now, as you watch this, invisible bullets are raining down on Earth from somewhere deep in the cosmos. Not radiation, not light, not radio waves. Actual particles, tiny, physical things, slamming into our atmosphere with energies so absurd that scientists literally had to invent new ways to measure them. We call them ultra-high energy cosmic rays, and they are perhaps the greatest unsolved mystery in all of modern physics. Here is the number that should stop you cold. The most powerful particle accelerator ever built by human hands is the Large Hadron Collider at CERN in Switzerland. It can accelerate protons to energies of about 13 teraelectronvolts. That sounds impressive until you realize that some of these cosmic particles arrive with energies exceeding 100 exaelectronvolts. That is roughly 10 million times more powerful than anything we can create. A single subatomic particle, smaller than an atom, carrying the kinetic energy of a professional tennis serve. One tiny particle, the energy of a thrown ball. That is not physics as we know it. That is physics mocking us. Now here is where it gets genuinely strange. In 1991, a detector in Utah recorded what scientists nicknamed the "Oh my God" particle. A single cosmic ray particle carrying an energy of 3.2 times 10 to the power of 20 electron volts. To put that into perspective, that particle was traveling so close to the speed of light that if you raced it from our Milky Way's edge to Earth, light would only beat it by a fraction of a hair's width over 2.5 million years. That is not a metaphor. That is the actual physics. One proton, moving that fast, arriving from God knows where. But here is the controversy that the scientific community does not always shout loudly. We should not be seeing these particles at all. In 1966, physicists Kenneth Greason, Georgy Zatsepin, and Vadim Kuzmin independently predicted something called the GZK limit. This theoretical ceiling says that cosmic rays traveling across vast intergalactic distances should lose energy by colliding with the cosmic microwave background radiation, essentially the leftover afterglow of the Big Bang that fills all of space. By the time a particle crosses hundreds of millions of light years, it should be stripped of most of its energy. Yet particles above this theoretical limit keep arriving. Either they come from somewhere surprisingly close in cosmic terms, within about 160 million light-years, or something is fundamentally broken in our understanding of physics. Both options are terrifying in the best possible way. The Pierre Auger Observatory in Argentina, the largest cosmic ray detector on Earth, covering an area of 3,000 square kilometers, that is bigger than the entire state of Rhode Island, has been collecting data since 2004. In 2017, their data suggested these particles likely come from outside our own galaxy, pointing generally toward regions dense with active galaxies. But generally is doing a lot of heavy lifting in that sentence. We still cannot pinpoint a single confirmed source. Suspects exist. Active galactic nuclei, supermassive black holes at the centers of distant galaxies that are actively consuming matter and launching colossal jets of energy, are prime candidates. Gamma-ray bursts, the most energetic explosions in the known universe, are another strong possibility. Some researchers point to magnetars, neutron stars with magnetic fields so powerful they would erase the data from your credit card from halfway to the moon. Any of these objects could theoretically act as natural particle accelerators, dwarfing anything humanity could ever engineer. What makes this even more maddening is the problem of tracking them backward. Unlike light, like photons, charged particles get deflected by magnetic fields as they travel across intergalactic space. By the time they reach us, their direction has been shuffled, scrambled, like a letter that was mailed but folded and refolded 1,000 times before delivery. We can barely read the return address. The neutrals, neutrinos, and photons that might accompany these events travel straight, and multi-messenger astronomy, combining gravitational waves, neutrinos, and light from the same event, is now our best detective tool. But we are still in the early chapters of that investigation. Here is what nobody is saying loudly enough. If we figure out where these particles come from, we do not just solve an astrophysics puzzle. We potentially unlock the physics of environments so extreme that the laws of nature operate in ways our textbooks have never described. Particle physics, cosmology, and our understanding of matter itself could be rewritten. The universe has been running a particle accelerator millions of times more powerful than ours for billions of years, and we are only now starting to collect the receipts. The telescope array in Utah and the Pierre Auger Observatory are currently undergoing major upgrades, with the Auger Prime upgrade adding new surface detectors and scintillators to better identify the composition of these particles, whether they are protons, iron nuclei, or something else. Results from these upgrades over the next decade could finally crack the case. Something out there, something ancient, violent, and incomprehensibly powerful, is firing particles at us with energies that should not exist in transit across the universe. And we are standing in our little blue dot, holding our detectors up like children catching raindrops, trying to figure out where the storm is coming from. If that does not make you feel simultaneously humbled and electrified about the universe we live in, I genuinely do not know what will. Follow this channel because we are just getting started on the deepest mysteries the cosmos has hidden from us. Now tell me this. If we finally discover the source of these particles and it forces us to rewrite the laws of physics, would that excite you or terrify you? Drop your answer below.